Hi, welcome to this lesson on trigonometry, trigonometric functions part 2. Let's have a look at question 1. We're given the graph of f of x equals 3 sine x plus 1, with x between 0 and 360 degrees, and it's drawn below. Line AB is parallel to the x-axis, and A is a point on the y-axis. Okay, so let's see if we can fill in some information. Okay, so A is here on the y-axis, so that's a y-intercept. So when A is 0 degrees, if we plug that in here, sine of 0 degrees is 0, times 3 is 0 plus 1. So the coordinate of A is 0 degrees 1. And because AB is parallel to the y-axis, we expect this y value also to be 1. So the endpoint here should be 360 degrees based on the given domain. And if you put 360 degrees there, you'll see that sine of 360 is 0. So that does make sense because we have 0 plus 1. Okay. What else do we have here? Well, let's look at the function, right? It's in the general form a sine bx plus p plus q. Now, the only parameters affecting the sine x parent graph is a and q here. A equals 3, so it's a vertical stretch of the original sine x graph by 3. And then it's the entire graph of 3 sine x is then shifted up 1 unit. Okay, any other information we can plot on here? Well, let's check if we can find the turning points as well. Let's see if they might be at the same coordinates we expect them to be. So if I plug in 90 degrees, sine of 90 degrees is 1, times 3 is 3, plus 1 is 4. So it looks like we have a maximum value there of 90 degrees, 4. And then if I plug in 180 degrees, sine of 180 degrees is going to be 0, right? And 0 times 3 is 0. And 0 plus 1 is just 1. So it actually intersects with the line AB as well. So that point here is at 180 degrees, and the y value is 1. Okay, it does look like it cuts the x-axis over there, so we could solve for that if we need it. And it also cuts the x-axis there. If I put 270 degrees, sine of 270 is negative 1, times 3 is negative 3, plus 1 is negative 2. So it looks like it has a minimum turning point here at 270 degrees, negative 2. So you can automatically see the range of this function f. It's from negative 2 to positive 4. And we expected that to change because the normal range of sine is negative 1 to 1, but we have the parameters a and q affecting the graph. Okay, so now they want the coordinates of b. Well, we've already logically deduced that out. That's equal to 360 degrees and 1. Calculate the values for x where f of x equals negative 1. So basically on this graph here, so negative 1 would be over here. So we want to see, so let's see visually, geometrically, how many solutions we expect. So in this period, we expect 2 solutions, one over here and one over here. This solution looks like it's bigger than 180 but less than 270. And this other solution looks like it's bigger than 270 but less than 360. So let's go ahead and work it out. Okay, so f of x equals negative 1, if and only if 3 sine x plus 1 equals negative 1. So I've substituted f of x into its function. So now if I subtract 1 on both sides, I get 3 sine x equals negative 2. And if I divide both sides by 3, I get negative 2 over 3. So let's get our cast diagram ready, because this is a trigonometric equation. Where's sine negative? That is in the third and fourth quadrants. So in the third quadrant, we're going to have, well, first of all, let's work out our reference angle. So the reference angle is always sine inverse, well, the trig inverse ratio of the positive number 2 over 3. I get 41.81 degrees. Okay, so the quadrant 3 solution is x equals 180 degrees plus that reference angle, so 221.81. Okay, and the period of sine is 360 degrees, the k is an integer, and then the fourth quadrant solutions is x equals 360 degrees minus that reference angle. So 360 minus reference angle, I get 318.19 degrees plus k times 360 degrees, where k is an integer. Okay, so remember we're working in this restricted domain. So if I put k equals 0 for the first one, I get x equals 221.81 degrees, which is a valid solution. if I take anything greater than or equals to 1 that's an integer, I'll be outside that domain. And similarly, if I take negative values, I'm going to be outside that domain. All right, if I put k equals 0 here, what am I going to have? X equals 318.19 degrees, which is valid. And similarly, if you take values, integer values that are bigger than or equal to 1 or less than or equals to negative 1, there's going to be no applicable solutions. So the only two solutions are these ones here. So let's see if they make sense. 221.81. Yeah, that's definitely within that, between those two values, so that makes sense. And then 318.19. Yeah, that makes sense as well. Awesome. So those are the 2 points there, the x-coordinates. All right. Lastly, we want to know if g of x equals k and k is a real number, then for what value or values of k or f of x equals g of x have no real solutions if x is between 0 degrees and 180 degrees. So we're going to need to be careful here because the full graph is on 0 to 360 degrees, but we are interested in this portion. So let's think about it. So algebraically, f of x equals g of x, if and only if, so these are the point of intersections. So f of x is 3 sine x plus 1, and g of x is k. So now, on x between 0 degrees and 180 degrees, the function f of x, which is 3 sine x plus 1, what y values does that function range between? So here's 180 degrees, and 0 degrees. So you can see the lowest value is 1 and the highest value is 4. Okay, so all the y values are between 1 and 4. Okay, so that's really important. So now I'll come back to this one here, and I'm just going to see that this 3 sine x plus 1, that is contained in this inequality here. So that means that k, which is the same thing here, must be between 1 and 4. So that is when you'll have valid solutions. All right, so therefore, no solutions, no real solutions, if and only if k is outside there. So k is greater than 4, or k is less than 1. And you can see that using a number line, because he has 1 and he has 4. So the solutions are valid inside this interval, but then they are not valid outside that interval. So less than 1 or greater than 4, where k is a real number. Okay, so that's doing it algebraically. We can also do it geometrically using the graph. So we know that this red graph here, that is when, if I take a y equals k line, remember y equals k, right, g of x equals k is just a horizontal green line over here, y equals k. So if I keep taking these y equal k lines, can you see they do cut the graph here, right? But that's greater than 180, so it's not inside that domain that we're looking at. The moment y equals k starts cutting is here. Okay, can you see now, as soon as it's equals to 1, it's going to cut the red graph twice. Greater than 1, yeah, it cuts the graph twice. Right, cuts the graph twice. And until you get to 4, and then it cuts the graph once. The moment you are greater than 4, the green line won't cut that red graph anymore between 0 and 180. And the moment you are less than 1, okay, it will no longer cut the graph between 0 and 180. All right, so that's looking at it geometrically and looking at it algebraically as well. All right, that's how you do this type of question. I'll see you in the next one.